Good day. So I just wanted to show a question on how the terms work. So because that would be the last video that we look at, right? Other terms in a frequency distribution. So sometimes you might get in between any multiple choice. It might have one part in a question for CXC, but sometimes you get a whole question on it. And this is one where they give you a whole question. It was back in 2006, and it was something they were starting to ask more and more when you look back at some of the more recent exams. So here we have the data below, are the right foot lengths of 25 students in a class, and we have 14, 15, and so on all the way up, right? So this is the 25 students. I measure the right foot and I record the data. But to make it a little simpler, we're going to put it on a frequency table, and instead of having 25 rows on the table, however much data we have, we're going to use the class intervals. So these were the class intervals. We would see 14 to 16, 17 to 19, and so on. And this is how often each of those occur. The first part is to compare and complete the table. So let me just go through the first one. 14 to 16 means they're looking at the numbers 14, 15, and 16. That's what that interval covering. And when we go back to the raw data at the top here, the ungrouped data, 14, 15, and 16, you realize there are 4. That's why they put 4 here. 17 to 19 means we're looking at the numbers 17, 18, and 19. And we want to see how much of those they have. So you realize I have 1 17, 3 18s, and 2 19s. So in total, this one going to be 6. That's how I fill it in. If you was to check 20 to 22, 20, 21, 22, 1, 2, 3, 4, 5, 6, 7, 8. That's how they get 8 as well. So that's how they fill out the table, just to show you. Now we want to fill out interval is missing, but like I said, this is just patterns. We would have done patterns before, so I have to figure out the pattern because it is a pattern as we go down. So 14 jump to 17 jump to 20 something 26, and the pattern will be the same on the same side. How much you jumping by? To jump from 14 to 17, it increased by 3. To jump from 17 to 20, it increased by 3. So that's the pattern. You're jumping by 3, and we'll see that 3 again a little bit later on. So 20 add 3, 23 add 3, 26. Same thing here. Same plus 3. 19 at 3, 22, 22 at 3, 25. So the missing interval is obviously the numbers from 23 to 25, because that's the numbers that are missing from the table. And again, just to keep notes, because we would have done a frequency table before with basic ones. If I was to add up all of this, it should total the 25, because this accounting for everybody in the class. 6 at 4, 10, 8 at 2, 10, at 10, 20, at 5, 25. So that was with the table. Let's look at some specific things that they could ask, and again, depending on the year, they could ask any of these. In this particular year though, they ask more than one, which is good to see what different things they could ask. So say the lower boundary at this interval, 14 to 16. So again, the boundaries are the 0.5. So each n number is called a limit. So this is the lower limit here. This is the upper limit. 0.5 less than the lower limit. So I'm minusing 0.5 or a half. The lower boundary going to be 0.5, and 0.5 more than the upper limit, we will have the upper boundary. So that would be the boundaries: 0.5 less, 0.5 more than whatever the limits were for that particular interval. So I just wanted the lower boundary. The lower boundary will be the smaller one with the decimal. So the lower boundary is 13.5 centimeters. So again, you need to know what the terms are. State the class width. So again, you could use the formula, or you could count how much numbers it's covering, or you could just follow the pattern. Whichever way you do it, the class width will be 3, meaning it jumping in 3s, it covering 3 numbers. And if I was to use upper boundary minus lower boundary, 22.5 minus 19.5, I'm still going to get the 3. That's up to you which one you want to use though. A student's right foot, part D now, measured 16.8 centimeters, and I want the class interval to which this belongs. You realize none of these had decimals in it up here, but that's the whole purpose of the boundary. The boundary accounts for the decimals, and that's why we would have said before, this one really running from with the boundaries 13.5 to 16.5. We would have do that one here already. This one really running from 16.5 to 19.5, and then this would have run from 19.5 to 22.5, and so on. So when I include the boundaries, you could realize 16.8 really fall in between the 16.5 to 19.5 range. Or in other words, if I was to round off 16.8, it's closer to 17 than to 16. So that's the account, because most of the time when we measure something, it might be exactly the number. So either we put approximate number or we put the exact number. So this would really be for the interval. This interval will really be the 17 to 19 interval, because the 17 to 19 interval, because of the boundaries, really running from 16.5 to 19.5 to account for those decimal values as well. We'd have done probability before as well. A student was chosen at random from the group. So because I'm choosing a student from the group, first thing I have to ask is, remember, once I'm doing probability, it's going to be a fraction. You have to understand that. A probability can be 2 and 5 and 10. It would be a fraction out of something. So the bottom number normally easier to get. So the bottom number in this case is, I want to choose a student from the class. So if I'm picking from the class, how many children do I have to pick from the class? So I have 25 students in the class, so automatically the bottom number going to be 25, because that's what I'm picking from. Just like if I'm flipping a coin, they have 2 options, so the bottom number going to be 2. If I roll in a dice, they have 6 options, the bottom number going to be 6. I'm playing 1 mark in playway, it's out of 36, so the bottom number going to be 36. Same thing with the pack of cards being 52 and so on. So in this one, it's out of 25, because I have 25 students to pick from, so the bottom number going to be 25. What I really need to figure out, though, the harder part will be getting that top piece. And this information here telling me what specifically I would like for the top piece. Greater than or equal to 20. That's what I want. So I want somebody with a foot size, right foot size, greater than or equal to 20. Now I could use the table, because the table available. I could use the raw data as well. We'll do both. But first, what does greater than or equal to 20 means? What numbers am I looking at? Greater than 20 and equal to 20 means I'm really looking at 20, because they say equal to 20. I want 20 and up. That's what I really want. So in terms of the table, or in terms of the numbers, I want 20 and higher than 20. So in terms of the table, in terms of the raw data, 20 and up is this part of my table. This part of the raw data. So how much people I have with a foot size 20 or more? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 out of the 25 people have a foot size greater than or equal to 20, or in other words, 20 and up or 20 and more. What if I want to use the table though? Table have 20 and I want 20 and up. So all of this is 20 and up. If you notice, this went from 20 all the way up to 28. Even though it didn't have a 28, they was just following the pattern with the class width. So that means this is 20 and up. So that means these are the people who have a foot size 20 and up. It's not looking like 15, because I have to add it up. 8 at 2 is 10 at 5 is 15. You realize I'm still going to get my 15 out of 25. And if I want, because we did fractions already and you're noticing it, it could break down 5 into 15, 3, 5 into 25, 5. The only reason we break it down, because if I don't see that answer there and it's a multiple choice question, this wasn't a multiple choice question though, so either would have been fine. But sometimes in the multiple choice paper, you would see that they break down the fraction. So just keep that in mind, that sometimes I'll still have to reduce if I do see the answer there. All right, next one. State the modal length of a student's right foot. So modal length means mode, and they ask for the modal length. These are not lengths, these are intervals. These are the actual lengths up here, so they want the mode from here. And again, if you remember what mode means which number occurs the most. So scan through that there and tell me which number occurring more than any other number. Some numbers occurring once. I've seen 16 occurring twice, 18 occurring 3 times, 19 occurring twice, 20 occurring twice, 25 occurring twice, 23 occurring twice, but 22 occurring 5 times. So because 22 occurring more than everybody else, 22 is the most popular foot size in the class. So 22 is my mode. Last question is the hardest and what I really want to look at. Calculate an estimate of the mean using the table. So we want to use the table. Once they say estimates and using the midpoints, that means we have to alter the table now, which would have been the last part of the note from last day. So that means I need to get the midpoints like they said. Now, when I see midpoints, that will be one of the terms, class midpoints. So I'm going to head up on next column on my table here for midpoints. And again, we know how to get the midpoints. Add up the two numbers and divide by 2. So that's 30 over 2, 15. But once I find one and I'm going to add up all of these, I just follow the pattern, which was to increase by 3 all the time. So this one going to be 15. This one will be add 3, 18, 21, 24, 27. So those will be my midpoints. And once I want to find the mean using the table, I need to get my totals column, because to get the mean, I need to add up all the numbers and then divide by how much numbers I add up. The only problem is I can multiply out the table like we did in the frequency table video. because this is not a number, this is a range. So how I was going to multiply 14 to 16 by 4? I can't. So what we do is we let the midpoint represent that by being an estimate at that interval, which is what we're using as 15. And that's why they're saying estimate at the mean, because it's not an exact answer we get in with this, but it'll be close enough for what we need. So once I'm using that to represent the interval, I multiply out my table just like before. So it'll be 15 times 4. So it come like saying 4 students on average had a foot size of 15. So 15 by 4, those 4 students' foot size gonna total 60 centimeters. These 6 students on average have a foot size of 18. So 18 by 6, 108. And then we keep multiplying all the table. 21 by 8, 168. 24 by 5, 120. 27 by 2, 54. So just like when we would have done the question on the previous frequency table to calculate the mean video, these are what the totals of the respective groupings going to look like, and then I add them up because I'm doing it in an organized manner. When I add up all of this, I'm going to get 510. That's not my answer though. That's how much everybody foot size add up to approximately. So it's how much everything add up to, sum all the numbers over the amount of numbers that add up. And again, don't be tempted to say 1, 2, 3, 4, 5 numbers. It wasn't 5 numbers, it was 5 numbers, but remember we're looking at how much people contribute to the 5 numbers, and that's where this number coming out from is really 25 foot sizes, right foot sizes I would take. So dividing this by 25, so the average foot size or estimated mean size of the right foot length in that class will be 20.4. And this is usually as hard as something like this would come. Otherwise, we'll have to draw a graph, which is what we're going on to next, the advanced statistical graphs. Cool.